Now, it's really important that you are careful and that you read what's on each axis of your graph, because otherwise you're going to interpret your graph as being something that it's not. So this is a speed time graph, and this is a distance time graph. Speed actually isn't written in there, but this is a speed time graph. So you can see there the two graphs have exactly the same shape. The motion is being monitored over exactly the same period of time, but they mean two different things. So if we look at the distance time one first, you can see the distance is increasing there. In this part it's increasing and it's a curve, but in this part it's increasing and it's a lovely straight line. So in this part, if it's a curve, that means it's accelerating. A nice straight line in a graph like this means that its distance is increasing by equal amounts, so it's got a constant speed or velocity. You can't see that. This part of the graph, if you look across, its distance isn't changing and therefore it's at rest. And this part of the graph, this time it's a nice straight line, but it is going down. So it's also a constant speed. But this time it's going down to 0. So this really is showing that it's actually moving in the opposite direction now, because it has got a negative velocity or negative speed. In this one here then, speed time graph, again you've got a curve in the first part, and that curve also shows that the speed is increasing by non-equal amounts in different time intervals. So therefore this is also accelerating. This part of the graph, which is a nice straight line, is showing acceleration, but it's constant. I'm going to write constant in there. This is showing just a constant velocity. And this is showing a constant deceleration. And I suppose I should have mentioned here, this is no speed, so it's at rest. And down here as well, this is not showing any more distance being covered, so therefore it's at rest too. So just be careful that different parts of each graph mean different things.